Welcome to my Switching, Routing, and Wireless Essentials course. This should be the CCNA version 7 curriculum. This is the second of 3 courses. Welcome to Module 1, Basic Device Configuration. The goals for this chapter are to be able to do an initial setting for a switch, setting up switch port access, remote access, setting up a basic router, and verifying directly connected networks. So first section is 1.1, configuring a switch with the initial settings. So before we talk about how to configure a switch, we have to talk about how the switch powers on. Switch power on is a 5-step process. First step is post, which is a power on self-test. It tests the CPU, the RAM, and the portion of flash that holds the file system. Step 2, it will load the bootloader software, which the bootloader is a small program stored in ROM that is ran right after post. Step 3, the bootloader will perform a low-level CPU initialization, basically turning on things like the registers. It will control whether physical memory is mapped and how much memory is actually allocated. And it will verify quantity and speed of memory. Step 4, the bootloader will initialize the flash file system that is located on the main board of the device. Step 5, the bootloader will locate and then load the default iOS operating system into memory. Keep in mind, a device can have more than one iOS. The default will be whichever one is set. Next, we can talk about the boot system command. The boot system command will actually let you set what iOS to load. It actually has 4 main parts. Boot system, which was the main portion of the command. Flash will be the storage of the device. It doesn't always have to be flash, but in this example it is. We will then give it the path to the file system. Here we're giving it a folder, and then underneath that folder or directory it will be the iOS device. Keep in mind that iOS file is not a .iso. It's not a .ios. It's not a .exe. It specifically is a .bin file. The iOS files are actually stored as bin files. Boot system can actually come from an array of storage. Doesn't necessarily have to be flash, but in most basic configurations, it is coming from flash. Next, we have to talk about, if we're looking at a switch, how does the switch look? Typically, if we're looking at a Cisco 2960, we'll have this diagram on the left-hand side will be on the switch, system, RPS, stat, duplex, speed, and PoE. SYST is short for system. Basically, is the switch powered on and receiving proper functionality? If yes, the LED will be on. Next, RPS is redundant power supply. This will show the RPS status. Next will be the status. That will be the port status LED. They should be green, and essentially when a port is active, it will light up green. Next is duplex. When it's green, it will indicate the port duplex mode is selected. Again, it will either be half duplex or full duplex, and then the lights may differ based off the duplex. Realistically, full duplex is the default, and that's what it should be at. Next will be speed, or port speed LED. When the LED is green, it will indicate the port speed mode is selected. On the actual switch itself, the ports will either be green or orange. Green should be speed of 100 megabits. Light of orange should be, it will be a gigabit connection. Next will be PoE, and this will represent if PoE is set on those ports. PoE is not enabled by default. PoE is not set up by default. You need to make sure that if you're using PoE that it's turned on the ports that are needing it. Again, to change between the stat, duplex, speed, and PoE, you would hit the mode button on the bottom left-hand side of the switch. In this example, it's right here. That would be the mode button. And it will cycle between status, duplex, speed, and PoE. You'll have one of them selected at a time. Next, we can talk about the lights. What do they mean? So, if we're talking RPS, if it's off, there's no light, there's no RPS. If it is green, RPS is present and is ready. If it's blinking green, RPS is up but not available. If it's amber, it's in a standby mode. If it's a blinking amber, an internal PS power supply has failed and the RPS is providing power. If it's alternating between green and amber, means nothing. Realistically, you can go through the chart. I don't need to go through each section. Some switches on the speed, when it is gigabits, will be orange. I know in the previous slide I said orange. Some will actually blink green. It all depends on the type of switch that you have. I did generalize it being orange, but on most Cisco 2960s, it will be blinking green. If it's PoE, again, you can go through the options there. Next, what happens if we have a switch and the system file system on it crashes? What do we do? How do we recover? So the recovery is a 5-step process. We're assuming you have physically have the device and you have a console cable. You will connect the PC to the device using the console cable, plugging into this. Here we're using a switch as an example. You'll be plugging the PC into the console port of the switch. You'll configure the appropriate terminal emulator and connect to the switch. Once you connect to the switch, you will then unplug the switch power cord. You will then plug it back in. That will be step 3, reconnect power. And within 15 seconds, press and hold down the mode button while the system LED is still flashing green. This will let you get into a recovery mode. Again, when you plug the switch in, you have within 15 seconds to press and hold the mode button. Step 4, continue pressing the mode button until the system LED turns briefly amber and then turns solid green. That will let you know to actually release the mode button. Step 5, the bootloader switch prompt will appear in the terminal emulating software on the computer. The bootloader command line support commands to format the flash file system. It will also let you reinstall the operating system. It will also let you recover a lost or forgotten password, for example. You have to know some basic Linux commands, Unix commands. You can navigate the CLI using things like dir. That will let you be able to see the different directories. Again, this can also be used for password resets if necessary on a switch, but you have to do it in a correct order. The big thing to recognize is when you power it back on, 15 seconds, within that first 15 seconds, you have to get in and hold the mode button to properly tell the switch to boot in the right prompts. Alright, moving on. How do we configure switch management? Again, we're going to be setting a console cable to a switch. You have to be able to set an address to a switch. That will be using a SVI or switch virtual interface, and they will be tied to individual VLANs. VLANs we'll talk about a little bit later, but essentially you have to give the switch an IP address to be able to remotely manage the device. So by default, the switch is configured to have its management controller through VLAN 1. That means all the ports are attached to VLAN 1 by default. You can modify this and change the default LAN if necessary. You can set a management LAN if you'd like. So to configure the management interface from a VLAN, you would go and you would type VLAN interface. You'd have to go to its configuration mode. So interface VLAN space 1, enter. That would let you apply an appropriate IP address. I have a switch, just basic switch, no configuration. I'm going to get into its configuration mode, and I want to apply an IP address. So I would do interface VLAN 1. Notice that will put me at a interface subcommand, IP address, and apply an appropriate address that's tied to your network. Make sure to turn it on. And that's it. You've just now configured a SVI on a switch. If you want to modify the management VLAN to say VLAN 99, you can actually set an interface for VLAN 99, but it will not actually show up and working or functioning until you actually create VLAN 99. Switches may need to also be configured for an IPv6 address. Not all Cisco switches are capable of doing IPv6. Older switches may not be. So to configure an IPv6 address on a Cisco 2960 running iOS version 15 or above, you'll need to actually enter the global command SDM preferred dual IPv4 and IPv6 default, and then reload the switch. This will let you do both IPv4 and IPv6. Realistically, we have a lab later that will outline how to do this for our switch configuration. Moving on, we can talk about how to set up addresses. Again, I did it via a terminal in Packet Tracer, but these are the commands. You'd go to the terminal, go to the appropriate interface, give it an appropriate address, set up IPv6 address if necessary, turn it on, and then save it and reload it. So next we have to set a default gateway. For a default gateway, assuming only one VLAN, we would be, again, go to the terminal. Once we're at our terminal, do IP default gateway and give it the appropriate address. Again, this should be your layer 3 device on your LAN. Typically, it will be a router. It'll be the router's LAN interface. And again, if you're not sure about this, I have previous videos that talked about the importance and functionality of a default gateway and how to determine what they are. Step 3 is verify the configuration and verify the interfaces. So you will do a show IP interface brief, and that will see if the interfaces are turned on. So again, I have my packet tracer, I log in, exit, I will do a show IP int brief, and it will show the VLAN and if it's up or down. In the lecture, they modified VLAN, they moved to VLAN 99. In my packet tracer, I did not. Again, we have labs that will explain that. Remember that just because the switch has an IP address, that doesn't mean the switch will route IP packets. A switch typically is layer 2, and all routing will be performed by a layer 3 device. So the switch, while it has an IP address, still needs to send all IP packets outside the network, destined outside the network, to the layer 3 device, or typically the router. Yes, there could be a layer 3 switch, but most cases it will go to a router. So again, basic switch should be able to cable up the switch, be able to provide basic functionality for the device, verify and test network connectivity, manage the MAC address table, and we will actually have a lab that walks us through those 4 parts. Questions, concerns, please reach out. Thank you.